Chapter 6 is all about chemical bonding, and there are multiple sections to this chapter that kind of build upon the information that you learned previously in the chapter to get to the biggest picture, which is how to actually draw and represent chemical bonds. So, the first part we have to talk about in section 1 is valence electrons. And remember, you can represent the electron with the E, lowercase e, and a little negative sign if you want to. So, what is a valence electron? We know electrons are found around the nucleus and they orbit and they have a negative charge. Valence electrons are those found in the outermost orbital or the outermost shell. So when looking at your periodic table and thinking back to chapter 5, groups 1 through 17, so the alkali metals, the alkaline earth metals, the transition metals or transition elements, the main group elements, and the halogens, those elements, majority of our periodic table, those elements do not have an orbital, an outer orbital that is completely full. So they look something like this. Their outer shells do not have a full octet, and you'll learn about the octet in a minute. Okay, so just know that they're not full. Because they're not full, they are easily able to either share electrons, give or donate electrons, or accept, take electrons. And when they do that, they form chemical bonds. That is why these elements are reactive, because they can react and form bonds. Group 18, however, the noble gases, if you remember back to chapter 5, we said they are non-reactive. They do not react. That is because they have a full outer shell, specifically with 8 electrons, except helium. So in all of the noble gases, excluding helium, helium is full with 2. It's so small it can only handle 2. But neon, argon, krypton, xenon, and radon, they have 8 electrons in their outer shells, and that makes them full. They cannot accept any more electrons. They can only have 8, and they're not going to give any away because then they would be unhappy. So because of this, they cannot form chemical bonds. And that's going to lead into the next couple of sections. So when trying to determine how many valence electrons each element has, look at the group number, okay? So group 1 elements, hydrogen down, have 1 valence electron. So group 1 has 1. Group 2, the alkaline earth metals, they have 2 valence electrons in their outer shell. We're skipping groups 3 through 12 right now. I'll tell you why in a minute. But groups 13, 14, 15, 16, okay, those are the main group elements. Group 17, the halogens, and group 18, the noble gases. If you take the group number and subtract 10, you determine the number of valence electrons. So group 13 has 3 valence electrons, group 14 has 4, 15 has 5, 16 has 6, 17 has 7, 18 has 8. So pretty easy to remember. But what about groups 3 through 12? What about the transition elements? Well, these elements, and you'll learn this in chapter 7, have a varying number of valence electrons. So we're just going to say we don't know, because you have to do a little bit more digging to determine that. So once again, valence electrons are the electrons found in the outermost orbital or shell of an element. And determining how many they have, you can use this chart, and that will determine the type of bonding that can happen.